Alright, problem 11 says use a graphic calculator to find the local maxima and minima, y-intercept, and roots of f of x equals negative 4x cubed minus 36x squared plus 22x plus 90. Sketch the graph and label it. So I've gone ahead and put this into my calculator here, negative 4x cubed minus 36x squared plus 22x plus 90. And I'm going to do a zoom 6 to begin with, and I can get a rough idea of what the graph looks like. I can tell I have min or max here in this zone right here and a min or max right here. So I can set my window up by going into the table and looking for the x values in this general area and in this general area, and then read the y's there, and that will give me the min and max I need to set for my y min and y max. So it looks like around negative 4, negative 5, somewhere in that range we have a minimum. So looking in here at the table, the smallest y I see is a negative 474, so I'm going to go into my window and set my y min to be below that, so I'll set it to negative 500. I'm going to go back in my table now, and it looked like I had a maximum somewhere around 0 or so by looking at the graph. Around 0 I have a y value of 90, so I want my y max to be above 90 so that I can see it. I'll make it 100. We'll graph it now and see how it looks. That looks good. We can see the min, we can see the max, so that should be everything we need. We'll bring that over now and paste that graph in so that we can work with it. So you would need to sketch this, but we'll just use the calculator graph for now. So find maximum, minima, y-intercept, and roots. Alright, so we would have a min right here, local min. We'll have a local max here. We'll have roots here, here, and here. And then our y-intercept would be right there. We can't really see it because of the max. So we'll bring the calculator back up and find that. So everything's going to go through second trace for this. So to find the minimum, I choose second trace option 3 for minimum. Hit enter. Calculator asks me what I need to tell it to give me the answer. So it says left bound. That means get left of the minimum you want to find. So I'm arrowing left. I get left of that minimum down there. Hit enter. Calculator then asks me for the right bound, so I arrow to the right, get right of this somewhere in this general area. Now hit enter, and guess, just hit enter, and it gives me that printout. So that would be the answer. I'll write that here. So it is negative 6.291 comma negative 477.255. Alright, now we'll find the max up here. So bring the calculator back over, made the window a little bigger so we could, the calculator a little bigger so we could see it. So that would be option 4 for maximum. I want the left bound. Calculator asked me for that, so I arrow near the left side of it, hit enter. Right bound, it asks me for next. I go right of that maximum, so hit enter, guess, hit enter again, and it gives me that value. So slide that over, and that would be 0.291 comma 93.255. So that would be the maximum there that my calculator gave me. Now we need to get the roots, so we go into y equals. We'll graph y equals 0 now. Slide this up a little. Graph y equals 0 and y2. So now go back in the graph and we'll find the intersection. We have 3 intersections, 1, 2, 3. Those are all roots. Second trace, option 5 for intersect. First curve, just hit enter. Second curve, enter. For guess, this one's out here about negative 10, so I'll type negative 10 in right there. And it is exactly negative 9.33, so that's one root. So roots, we have one at negative 9.33. Bring that over and we'll do the next one. So second trace, option 5 for intersect. First curve, enter. Second curve, enter. Guess, this time it looks like it's about at -1 or so. So for my guess here, I'll type in -1, hit enter, and it's -1.396, -1.396. Find that last one. Second trace, option 5 for intersection. First curve, enter. Second curve, enter. On guess, this time it's about at 2, it appears. So I'll type 2 for my guess, hit enter, and it is 1.727, positive 1.727. All right, now for the y-intercept, that's the last thing that we need. So the y-intercept, we can just simply go in the table and look where x is 0 when y is 90. So that means that the y-intercept is 0, 90. So that answers all of the questions for problem 11, and we'll use this information in the remaining problems 12 through 15 on the review. All right, number 12 says, from problem 11, so using that polynomial up here that we used before, this one, find f of -2.07. So that's when x is -2.07. We could set up our table to do that, but it's just as easy to use the graph. Second trace, all of these options are under there. We'll use option 1 for value. We'll hit enter. Flashes x equals, allows me to type in the -2.07. Hit enter, and it gives me the y value, which is what the answer is, -74.317. -74.317. So that's 12. Number 13 from problem 11 lists the intervals over which f of x is greater than or equal to 0. So scrolling back up here, that would be all of the sections. Actually, let's pull up the graph again. So that would be all of the sections to the left of this root and between these two roots. So that would be this section over here would be -infinity up to the root at -9.33. And this needs a bracket because it says greater than or equal to 0. And then we could put the union symbol, and then the rest of it is between those two roots right there. That's where it's above 0 in the graph. So the next interval would be from the middle root, -1.396, to the far right root, 1.727, both getting brackets. So that's it for number 13. All right, problem 14 says from problem 11, the polynomial we've been working with, list the intervals over which f of x decreases. Okay, there are two intervals that it decreases on, and that would be this section right here and this section right here. So we'll use some of the values we've already written down to answer this question. So this interval right here would be -infinity up to the minimum x value right there, the x value of that min, which was -6.291. -6.291. And then again, this interval would be from the x value of this local max up here, which we found to be up here earlier, 0.291. So 0.291 to +infinity. And we could put the union symbol between them. So that one is 0.291 to infinity. This area where it's decreasing is -infinity to -6.291. So that answers number 14. From problem 11, find where f is equal to -100. So let's bring the calculator back in. We go to y equals, we type in -100, that's where y is -100. Graph it, and we'll find the intersections. So -100 cuts across. There are actually 3 answers. I'm going to bring this graph over for us quickly. And those answers would be here, here, and here, those 3 intersections. So second trace, option 5, intersect. And we find the middle one first, -2.28. So x equals -2.28 is one answer. We'll have 3 here. Get that set up. Second trace, option 5 for intersect. First curve, enter. Second curve, enter. For this guess, I'm going to type in -10 to find that leftmost intersection. So that would be -9.03. And last one, we'll find the far right intersection there. Second trace, option 5 First curve, enter. Second curve, enter. For a guess, this time I'm going to type in +2. Looks pretty close. And it is +2.31. So that is it for the review. That's all the questions done. Go through this and you'll do great on the test.